Hello children, today we will learn about tangent galvanometer. What is tangent galvanometer used for? It is used to measure small current. Also in practical part you will measure using this tangent galvanometer, you will measure horizontal component of Earth's magnetic field. This tangent galvanometer, it uses moving magnetic type. Moving magnetic type is used in this tangent galvanometer. We will see what is that moving magnetic type, right? Now, what is the principle used in this tangent galvanometer is tangent law, right? Tangent law is the principle used here. This tangent law might be a 2-mark question, children. Now, what is tangent law? We will see. You can consider two crossed magnetic field. Okay, two crossed magnetic field. B and BH. Okay, one of the magnetic field is BH and another magnetic field I will take it as B. These two magnetic field are mutually perpendicular to each other, right? In this case, if we suspend a magnetic needle, see, imagine this to be the magnetic needle, okay? If you suspend a bar magnet or magnetic needle, what happens? This needle will come to rest in the resultant of these two field. Needle settles down in the direction of resultant of two field, right? So by tangent law, you can say that when a magnetic needle is suspended in two crossed mutually perpendicular magnetic field, the needle will come to rest in the direction of the resultant of two field, right? This is about tangent law. Mathematically, you can express this as, from this, if you consider a triangle, if you consider this as a triangle, this value will be BH and this part will be B, right? This will be B and this will be BH. Now if you take tan theta, what do you get? Opposite side is B divided by adjacent side. This is adjacent side, that is BH. So B is equal to BH tan theta. This is the mathematical expression for tangent law is B is equal to BH tan theta. You should know what is B and what is BH. Later we will say, I will give the explanation for this. Later we will see what is B and BH. B is the magnetic field produced by this TG coil. TG coil is circular in shape. That is if you pass current to the TG coil, it will produce magnetic field. So B is the magnetic field produced by TG coil carrying current. Okay, TG coil carrying current. The letter I represent current. So B is the magnetic field produced by the TG coil carrying current. So what is BH? It is nothing but horizontal component of Earth's magnetic field. Horizontal component of Earth's magnetic field. Horizontal component of Earth's magnetic field is BH. Usually it will be in the direction of magnetic meridian. What is magnetic meridian? It is the imaginary line connecting the north and the south magnetic pole of the Earth. Earth oda magnetic north and south connect பண்ற அந்த line தான் magnetic meridian சொல்லலாம். And the magnetic meridian direction only the horizontal component of Earth's magnetic field lies, right? Remember this law, tangent law expression, B is equal to BH tan theta. Next we will see about the construction. Otherwise you can say about the description of this diagram, okay, of this tangent galvanometer diagram. For that, roughly I will draw a diagram. It consists of a non-magnetic vertical frame. Okay, what I am drawing is a non-magnetic vertical frame. Draw it as a double layer. Okay, you can draw this as a double layer. This is the vertical circular magnetic frame. What is this? Vertical circular non-magnetic frame. What do you mean by non-magnetic frame? It is made up of wood or brass. Okay, so this is the non-magnetic vertical circular frame. Actually in this there will be a coil. Okay, this on this frame you are going to wind the coil. You are going to wind the coil in this. For that you can take a coil, you can make two turns, right? You can make turn 1, okay, and turn 2. So, and not only two turn coil you have, you will take another coil, okay, different coil, and you can make 5 turns in this, right? I will differentiate this. 1, 2, 3, 4, 5. You can wind 5 turn coil, and also third coil can be taken and you can make 50 turns in this. So this coil consists of 3 different coils of 3 different turns, 2, 5 and 50 turns. What is the purpose of using different turns, right? See, if it is used, 3 different coils are used to measure current of different strength. If you want to measure minimum current, you can use 2 turn coil. Maximum strength, if you want, you can use. If you want to measure the current of maximum strength, you can use a 5 turn or 50 turn coil. So depending upon the strength of the current to be measured, you can use it any of the coil, 2 turn, 5 turn or 50 turn. Okay, so on this magnetic frame, right? Next it consists of this TG consists of a horizontal circular turntable. This is the horizontal circular turntable. Okay, this is horizontal circular turntable. This will be flat on the surface. Now this horizontal circular turntable has 3 leveling screws. Whatever I am drawing is 3 leveling screws. Okay, it has 3 leveling screws. Now on this horizontal circular turntable there is an upright projection. Whatever I am drawing is an upright projection, right? This upright projection is like a pillar which carries a compass box, okay, it will carry a compass box here, right? What will be there in the compass box? Magnetic compass box, already you know, right? So this is the magnetic upright projection. What is this? This is upright projection, and you know this is horizontal circular turntable. This upright projection carries a compass box. It carries a compass box, right? What is there in the compass box? That is, it consists of 2 things. One is a magnetic needle. Okay, a magnetic needle. This is whatever I am drawing is a pivoted magnetic needle. Okay, magnetic needle and an aluminium pointer. Okay, I will draw the aluminium pointer here. It consists of a magnetic needle and an aluminium pointer, which are at right angles to each other. Magnetic needle and the aluminium pointer are at right angles to each other. What else is there is, you have a circular scale. Okay, there is a circular scale on this compass needle with 4 quadrants. 0, this is 0. These two opposite sides are 0, 0. These two are 90, 90. Okay, I will write it out. This is 0, this will be 0, and this will be 90. So, sorry, this will be 0. Opposite two sides 90, 90, 0, 0. So, you can see 4 quadrants. 1, 2, 3, 4. So, compass box consists of a a circular scale. It consists of a circular scale with 4 quadrants. So to sum up, you can say that compass box consists of a circular scale with 4 quadrants, and it also consists of a magnetic needle and an aluminium pointer, which are at right angles to each other, right? The upright projection supports this compass box, right? So this is all about the description. And one more thing you have to note down is the center of this magnetic needle. Okay, this is the suspended magnetic needle or pivoted magnetic needle. Center of the magnetic needle and the center of the coil, this vertical circular frame coil center and the magnetic field center, both should coincide. That is also you have to remember. Okay, this is all about the diagram. Let me repeat, children. So it consists of a vertical circular non-magnetic frame, and the second part of the apparatus is horizontal circular turntable with 3 leveling screws. What are these? These are 3 leveling screws. Now this upright projection, it carries a compass box, and the compass box already have described here, with a magnetic needle and an aluminium pointer with a circular scale with 4 quadrants. And this vertical frame, over this vertical frame you have wound coils of different turns to measure different current strength. Okay, so I told you that it consists of 2-turn coil, 5-turn coil and 50-turn coil, right? This coil, after winding this, right, see here you have screws like this. After putting 2 turns, one end of the wire is connected here and another end of the wire is connected here, right? After you take the second coil, after making 5 turns, one end of the wire, the coil will have 2 ends, right? One end is connected to this end. Take it into the vertical frame, wind it 5 times and connect the other end to this point. Okay, this is 5-turn coil. Same way 50-turn coils. While doing the experiment, if you want to select a 2-turn coil, means you can use these 2 screws, right children? So this is all about the description. Okay, you have to explain about this point number. So while writing about the description, what will be the first point you will write? It consists of vertical circular non-magnetic frame. Okay, non-magnetic frame, and the second part is horizontal turntable with 3 leveling screws. Okay, and the third point is upright projection supports what? Supports compass box. Okay, you want to write about compass box. Before that we will explain about this coil. Okay, what you will write? Circular coil is wound on non-magnetic frame. Okay, circular coil is wound on non-magnetic frame. Okay, this circular coil is of 550 turns to measure current of different strength. Okay, this point also you can write different strength. What is the purpose of using 3 different coil? Then to explain about compass box, what will you write? Compass box, it consists of pivoted magnetic needle. Okay, pivoted magnetic needle and aluminium pointer. Okay, aluminium pointer, right angles to each other. Then circular scale is there, right? Circular scale has 4 quadrants. Right children? And what is the another point you have to write? The center of the magnetic needle. Last point, what you can write? Center of the needle and center of the coil. Okay, of the coil coincides. Center of the needle and the coil coincides, right? Center of the needle and the center of this circular coil, they will coincide. This is all about the description. Got it, children? Next we will learn the theory. Now we will see the theory. Okay, that is actually now we are going to derive formula for BH in this. First thing, what now we will discuss about the theory, right? First what you have to do is you are not going to pass current, okay, to the coil. So no current is passed through TG coil. Okay. The small magnetic needle which is in the small magnetic needle in the TG coil, okay, it will be this small magnetic needle in TG. It aligns along BH, okay, that is, it aligns along horizontal component of Earth's magnetic field. This horizontal component of Earth's magnetic field, already I told you, it is along magnetic meridian. You need not worry about this, what is a magnetic meridian and all. That is the line joining north and the south pole. If you keep the magnet, okay, I mean TG coil along north-south direction, that will be the direction of BH, okay. So when no current is passed through the TG coil, the magnetic needle in the TG coil, it will align along the BH, okay, along the horizontal component of Earth's magnetic field. Then what you have to do is you have to pass current, okay. Current passed to the coil, to the TG coil. You can select 2 turns or 5 turns, and you can pass current to the coil, okay. Now what happened? Needle gets deflected, okay, needle gets deflected. Now you have to note down the angle of deflection, note down theta, the angle of deflection, right? Now you have 2 magnetic field, okay. You know that this current carrying coil, this is the TG coil, this is the TG coil with current. What is this? This is the TG coil with current I. The magnetic field produced will be in this. It will be perpendicular to the plane of the coil. It will be along the axis. Magnetic field produced by this current carrying coil will be perpendicular to the plane of the coil. Okay, and it will be also along the axis of the coil. Got it, children? So what is this B? What is B? B is equal to, already have learned the formula, mu naught magnetic field produced by a circular coil carrying current. B is equal to mu naught Ni by 2R. Okay, 2R, where R is the radius. This is the radius of the coil. Okay, radius of the coil. So this formula already have derived. The other magnetic field is BH is horizontal component of Earth's magnetic field. Horizontal component of Earth's magnetic field. Earth's magnetic field. Okay, this B and BH are perpendicular to each other. Okay, how? You know that BH is along north-south direction, right, children? You have to arrange the TG coil in the magnetic meridian. That is, this coil, you have to place it in the north-south direction. Then only you have to pass current. So this B is the magnetic field produced by the circular coil carrying current. So in the TG coil, there is a magnetic needle, right? That magnetic needle. You look at this diagram, children. There is a magnetic needle here, right, in the TG coil. It will come to the deflected position. You can see first it is in the north-south direction. If you pass current, this needle will come to the deflected position. In the TG coil, initially the magnetic needle was like this, right? Aluminium pointer and magnetic needle was arranged like this. If you pass current, the needle will get deflected to some other position. Okay, so the magnetic needle, it will come like this, and the aluminium pointer will be deflected through certain angle. Say it has been deflected to 45 degree. That theta is 45 degree. Both the ends of the pointer both will show the same reading 45 degree. So this is theta. Okay. So when the magnetic needle is suspended between these two perpendicular magnetic field, note down theta. In this case I told you it is 45 degree. Okay, for example, now you know the formula. Let it be equation 1. You know by tangent law B is equal to BH tan theta, right? Now you can take this as equation 2. So you can substitute equation 1 in 2. What do you get? If you substitute, instead of this B, you can substitute this value, mu naught Ni by 2 r, that is equal to BH tan theta. If you find out, if you take BH, what you will get? Rearrange, you get mu naught Ni by 2r into tan theta. Okay, so this is the formula to calculate magnetic horizontal component of Earth's magnetic field. Mu naught is the permeability of free space, and you should know the value of mu naught, that is 4 pi into 10 power minus 7 Henry per meter. N is the number of turns, okay, of TG coil, number of turns of coil. I is the current, already you know I is the current you pass through the coil. And what is R, children? Radius of the circular coil, radius of TG coil. For that you can find the circumference of the coil, and then from that you can calculate R. So theta is the angle of deflection. Theta is angle of deflection. So all the values you know, and you can calculate. If you substitute here, you can find out BH. Right, children? Now you need certain, while using this TG coil, you need the certain precautions. Precautions has to be taken, children. What are the precautions you can take while using this instrument is, before using this, you have to remove all the magnetic materials, nearby magnetic materials. Okay, you have to remove all the magnetic material. What is the second thing you can do is, you have to keep these precautions has to be made before using this TG coil, children. What are the precautions is, near the magnetic material near the TG coil should be removed. The next thing you have to do is this vertical frame. I'll show you this vertical frame. This vertical frame, this vertical frame should be exactly vertical, and this magnetic needle, it should be horizontal, right? This vertical frame should be made vertical, and this needle, magnetic needle on the compass box, should be made horizontal. For bringing this adjustment, you can use spirit level and also these 3 leveling screws, right? Then another thing is, before starting the experiment using this TG coil, you should make sure that this pointer should read 0 0 degree. Okay, 0 0, aluminum pointer should read 0 0. And fourth one, what you have to do is, this plane of the coil, actually you are seeing like this, right? Plane of the coil, if this plane of the coil, it should be kept along north south direction. North south direction, if you keep this same vertical frame, it will appear like this, children, if you place it in the north south direction. Okay, now this plane of this coil, it should be kept along magnetic meridian. Okay, plane of the TG coil should be along the magnetic meridian, and aluminum pointer should read 0 0. Okay, so all these 4 precautions has to be taken before using the TG coil. I hope you understood about TG coil, children. Thank you.